All right, wonderful to be here with you all today. As mentioned, my name is Bree Jimenez. I am an associate professor at the University of Texas in Arlington. And luckily, we've had horrible hailstorms this morning and last night. So hopefully we are in the clear for the next couple hours. So I'm excited to be here today at the Patton Conference and to be able to share the next hour with you. I would love, I'm going to try to get you guys kind of involved this morning. And again, please, at any point today, while we're together or at the end, put some questions in the question and answer boxes. I'd love to hear your questions or thoughts, or if you want me to dig a little bit deeper into some of the topics we talk about today, I'm happy to do that. I did want to just start off with just a quick little background. I did teach elementary school and high school and students with extensive support needs, but have spent really the last 15, gosh, I'm older than that, 15, 20 years, digging a little bit deeper into how to build general curriculum access for this population of students, meaning those with intellectual disabilities and developmental disabilities, including autism, multiple disabilities. But also really thinking about what does this mean and how do we build our practices so that we can create more inclusive opportunities for all students in our general education classrooms. So today I wanted to focus on really kind of some of the nitty-gritty, the actual think about the theory about why we're doing this and a little bit of the research of what we know, but also then dig deeper into how can we actually do this. And I've got some videos to kind of show and a little bit of research to review that could really be kind of like a research to practice opportunity once we really have a good solid foundation and kind of all think about what we know about creating meaningful access to the curriculum. And I think that's really important, that we don't just think about math for the sake of math, but we think about how it's meaningful to our students and how to use those research-based practices. So we will talk today about the research and what we know works and what we've seen over and over to be productive and feasible for educators in the classroom when it comes to thinking about personalized education and math instruction for students. And we're often talking about, the 1%, students with the most significant disabilities, those who are on alternate achievement standards. But I think, if that's not the population you work with, I think that what we talk about today absolutely goes across the board for students with more high incidence disabilities as well. We'll talk about explicit early numeracy instruction, grade aligned math instruction, and embedded systematic instruction. So we've got a lot to cover in a very short period of time. But hopefully this kind of gives you what you need to kind of dig a little bit deeper. And in your handouts, there's some other supports, and I'll mention those as we go along today. So when we think about inclusive education, if I think about the must-haves, it's the things that have to happen. I think about students gain access to the general curriculum and that they show proficiency in core academic content areas. So we know that we're not just going to, have inclusive education and the students are just there. They're just in the classroom and physically included, but we need to make sure that students are actually gaining general curriculum access and that they can show what they know. The other must-have is that we know that our schools need to provide evidence of student learning, and that's a requirement of IDEA. Andrew case continues to show that it's not just enough to say our students are there or that they couldn't do it. We need to have evidence of their learning, and we need to have evidence of high instructional strategies that are actually happening in the classroom to make that learning happen. But what we also know is that while the number of students with ASD and IDD receiving instruction in inclusive classrooms has increased over the past, maybe decade and a half, it's at a much slower rate for students with more significant disabilities. We're just not, we're or not making the same growth and gains in ways to support students with more extensive support needs in the inclusive classroom. However, we do have instructional strategies out there in research to use. And so today we're really kind of focusing on what do we know in maybe in our separate settings, what do we know works? And what do we also know works in inclusive settings? And how do we kind of marry the two of those together? Because we don't want to throw the baby out with the bathwater. If it's working and students are learning, we should be looking at what are the instructional strategies and how do they apply to various different settings. So with inclusive education, we know that, there's a big call and we need to be upping the ante. We continue to look at funding, Office of Special Education, Department of Ed, IES, we continue to see federal funding support for inclusive education. And we need to act to that call by not only being the researchers who might do that research, but being the educators who are trying to use some of that research and bridge some of that in our own classrooms, in our own schools, in our own districts. And so it's more than just that physical placement. We know that. And I think that's where sometimes inclusion gets a bad rap, is where we kind of have focused on this idea of, put the kid there and they'll learn, or it's their right to be there. Well, it's also their right to learn. And it's also their right to have educators who know what to do when they're there. And I think that the view I take is I do believe that we can probably teach any child, even those with the most significant disabilities, in the inclusive classroom, and we could teach them to do anything. The problem is that I don't have necessarily, as a teacher, I don't have 9 hours to plan every lesson with a co-teacher and then have, all my peers know exactly. I need it to be feasible. I need inclusive education in my math education to be able to be something that I can feasibly do as an educator with 12, 20 other students on my head count and multiple different general educators that I might be working with. So I think that feasibility is probably one of my biggest concerns, is that we can probably do anything we want, but is it feasible and is it sustainable as a teacher? Because there are a lot of balls that we're juggling, and some are glass balls that we cannot drop. And so we need to really make sure that we're thinking about ways to do teaching, to do our jobs in ways that we can sustain and we don't burn out and we don't go crazy in the meantime. So it's really important that we think about this, but we also think about making sure that for our students, we can actually measure their progress and we can measure their academic gains. And so part of that means that we've got to really think about, how do we put all of these pieces of the puzzle together? It's not necessarily easy. So what concerns do you have about supporting students with extensive support needs, to those with intellectual disabilities and or autism, developmental disabilities, multiple disabilities in the inclusive classroom? I would love to know. So if you could start off with, in the discussion box, just putting maybe a concern you have about serving this population of students in the inclusive math classroom. Yeah, good one. Absolutely. The pace. That's a big one. It goes so quickly. Yeah, behavioral needs. I think that's a really legitimate one. Both from a behavioral standpoint of like readiness skills, being able to answer questions. Absolutely. I see prerequisite skills coming up. Absolutely. Yeah, concepts. Tracy, that's a good one. And I'm glad you brought that up in math, and we'll talk a little bit about that. But, sometimes we think about just number instruction, but conceptually, mathematics and conceptual understanding and procedural understanding is such a huge component of math education. It's not just filling in the gaps, the jargon. I love it. Yes, I think this is really, really great. And I 100% agree with every single thing that's been put in here. Teacher readiness, and I saw general education teacher being willing. And I'm just going to throw this out there, guys. And I know many of you might be the special educators. Some of the research is also showing that us as special educators are sometimes the barrier. And I've heard this, it's like my babies, I know what to do with my babies. And really thinking about a team is that everybody needs to know what to do with our babies, kind of thing. And it's been interesting, some research that we've done, one of my colleagues, Tammy Barron, and I, working with general educators, special educators, and paraprofessionals, and using qualitative research to then inform our quantitative single case research. What we keep finding sometimes is that our special educators tend to be the ones that are the most apprehensive, even more so than our general educators. So that's been really interesting to see. So I 100% agree with everything you guys have said, and Susan, great one about the explicit instruction, and that kind of goes with the baby in the bathwater. We know what works for our kiddos, and we've got tons of research to show it, but we don't want to lose that. And sometimes that's not really the way things have been going in the general education classroom, and maybe it is in some. I would, argue to say that explicit instruction's effective for all learners, especially at the very beginning when they're in acquisition. And then we fade some of those supports over time. But what we know, and some of those barriers and concerns that you all just brought up, is that we know that our kiddos have intense support needs. That's been documented. That's one of the reasons that they, have the categorical label that they do, which is to help them receive the supports that they are entitled to. We know that some of those barriers for those students are multifaceted, and many of the things that you brought up, like behavioral support needs. Communication is a big one. Some of our students are nonverbal. Some of our students have limited vocal verbal behaviors. Some of our students need very specific use of assistive technology or different response modes, eye gaze. Maybe some of our students use different type of technology. And so are they going to be able to really, communicate their needs? And of course, the prior knowledge in which they may not have already have not acquired, and it's probably both, have not ever been taught. And so, when we think about both of those things, like, our concerns are legit. They are very legitimate. And I think that if we were to just dismiss them and say, oh, it'll all work out, co-teachers, it'll all just be perfect, that's not really the real world. And so we've got to address those, and we need to think about those and recognize that they are barriers, and they are potentially barriers that I would hope one day we could kind of move past, but some of them may, they're not. The idea that our students have behavioral support needs that are, different or more intensive than some of their other non-disabled peers, that's probably not going to go away. So what do we need to do in the meantime, or how do we kind of bridge all of these concerns that we have, the barriers that do exist, and then how do we help support them in more inclusive practices? So our plan today is to talk about embedded instruction. And if you notice, I have capitalized that. I'm not sure, formally if there's a big EI and a little EI, but I think the idea meaning that there is something very specific, and we're going to define what is embedded instruction that we're talking about today. We're also going to talk about the use of specially designed curricula that may be part of an inclusive classroom. So maybe there are supports that are research-based, things that we know have research to support using them for students with more extensive support needs, but they've generally been used in a separate setting, but they're working. So how do we, again, not throw the baby out with the bathwater? And then embedded instruction across the school day. What does that actually mean? What does that look like? And what about, we might talk about math skills, but we've just addressed a bunch of other skills that our kiddos need, and they need to be taught, and they need explicit instruction on, like behavioral support needs, communication, social skills. And so we need to actually address those things as well, both grade aligned and early numeracy. So we're going to start off with systematic instruction. And so systematic instruction is an evidence-based practice to support students with ASD and IDD. We know over and over and over again, and you guys do have a copy of this PowerPoint as one of your handouts, so you can go back, but these literature reviews over and over and over and over keep telling us that we can teach academics, we can teach social skills, we can teach vocational skills, we can teach everything down to mathematics using good, explicit, systematic instruction. And so when we think about it, we've got to stand upon the giants who came before us, who have done a lot of this work, who've said, this is what works. And so how do we take what works and make it feasible and sustainable in other situations? One of the things to note is that not a lot, some, which we'll review, of this research has been done in inclusive classrooms. So we need to think about what is working, and then what does it look like in inclusive classrooms, and what research has been done in inclusive classrooms to help us kind of figure it out. So I really like this graphic based on the research that comes out of the Spooner and Root, Saunders and Browder literature review on mathematics for students with moderate and severe developmental disabilities. So that would include some students with autism who also have intellectual disabilities. And what we know over and over that we see is systematic instruction, but there are specific strategies within systematic instruction that we keep seeing in the research. But I also wanted to kind of make a note of these other ones, because if I were to think about, like when I work with our pre-service teachers at UTA, I make them print this, and I'm like, this is what I want you to hang in your classroom, so that when you're planning your math lessons, you're coming back and going, do I have some or most of these components in my lessons and units? Maybe not all, but most. And so, do I have graphic organizers? Do I have some manipulatives? Do I have explicit instruction? Do I have systematic instruction procedures? So it's not just the what, like the graphic organizer or the manipulatives, it's the how am I teaching students to use those graphic organizers? How am I teaching students to use those manipulatives? So it's the teaching. It's more than the stuff. It's the how do we instruct? And so I'm kind of starting here very generic, not saying that this is an inclusive classroom or a special education classroom or anything in between. This is just good teaching. So this can be applied everywhere. And just wanted to show you guys just a couple examples of what I mean by some graphic organizers. And so, we know that this is a research-based practice, and it's an evidence-based practice. And it's actually one of the evidence-based practices, research-based practices that is suggested by the What Works Clearinghouse for students who struggle in mathematics, is the use of graphic organizers. And so those visuals are really great supports. So when we think about that inclusive math classroom, this should be existing across inclusive or anywhere. These are the things that we know are supportive for students. And so, you might have students, wide range of students. I'm assuming that you guys, support teachers who support them, that you have in your life one way or another. And so think about just general adaptations that might be made. So, it could be that instead of the word rabbits, we've got a picture icon of a rabbit and the word rabbit. Maybe we have, a number of rabbits, and then we say ×2, and we've got 2 boxes, and they move those rabbits and then they replicate that. And so maybe it's a more tangible way of representing ×2. So they've got 2 boxes. Maybe it's actual 2 physical cups and little rabbits that they're moving into it. The idea is that we can represent these through multiple different ways and make them maybe more appropriate for the students that you serve, depending on the barriers or the needs that they have. So along with graphic organizers, some of the other examples that we know from the field of special education and from the area of looking at students who struggle in mathematics is that we know that systematic instruction keeps coming up over and over and over. So, it's kind of like what is the baseline in your math classroom? If I were to come and watch, what I would be looking for is, are you using explicit instruction? Are you using systematic instruction? Are you using tangibles? Are you using graphic organizers? And I would look for most of those most of the time. And I think that's where we start to kind of say, okay, if we know that's good math, let's think about what are those strategies, and then how do we bring them into our general education classrooms? So I wanted to start today around systematic instruction, spend just a few minutes making sure that we're all kind of clear of what I mean, or how we define time delay, task analysis, and our prompting hierarchies. And this might be a review for many of you, but I thought I would just show a couple little videos real quickly to kind of think about it. So time delay is a form of systematic instruction. It is a research and evidence-based practice to support mathematics for this population of students. And it's used for discrete skills. So things that we want our students to learn, such as number identification. It could be used for symbols like greater than or less than or equal. It could be used for, if you needed it, number words, or it's things that are discrete. It's not like sounding out words, it's sight words. This is where a lot of the research is. So thinking about what this looks like. So I'm going to show you a quick example with some sight words.
Callie, touch me. Good job, Brian. Let's watch Aaron. Aaron, touch me. Me. Good job. Jadasia's turn. Jadasia, touch is. Good job. Callie's turn. To Callie, touch is. Good job. Touching is. And Brian's turn. Touch is. Good job. Mo's coming around to give some kisses. Good job. This time Mo wants you to find the word, Aaron. And if you need help, remember Mo can help you by pointing to the word. But Mo wants you to find it all by yourself. We ready?
Yeah.
All right. Thank you. Let's watch DeCallie. Ready? DeCallie, find my. Good job. What word? My. Aaron, let's watch Jadasia. Jadasia, find my. Good job. Ready, Aaron?
Yeah.
Aaron, find my. Good reading. Good job. Jadasia, find is. Good job. What word?
Yeah.
Good.
So time delay is a errorless procedure where, and there are different scripts out there that you can use. I did include a script, I think, in our handouts to talk a little bit about this. But thinking about time delay procedure, it's where you use kind of a zero delay. And then after a student has practiced that with errorless learning, you move to a delay round where you can assess whether or not they're understanding. So this is a strategy that's been used in numeracy and math lessons, to where in the greater math lesson, a teacher might embed time delay opportunities for a student to recognize numbers, let's say. So rather than just doing number bingo at a separate time, we're embedding that idea of using that systematic prompting procedure during a lesson. Okay. And so task analysis is another area that we've looked at for chained skills. So all skills that we teach are either discrete or chained. And chained is actually just a bunch of discrete skills that have to, proceed in a process. So with the task analysis, I'm going to show you, this is just a few minutes of this, but again, breaking apart something larger. And so often we're familiar with task analysis, or the concept of task analysis, when we think about maybe somebody tying their shoes, or cooking, or riding a bus even. First they need to open it up, figure out which bus to ride, then they need to, do this, then they need to pay, then they need to. So the idea is we can break apart things such as, solving an algebraic equation. Actually, just addition is not a discrete skill. It's a chain skill. There are many steps that a student needs to take to add two things together. And when we start to break them apart, it allows us as educators to be able to teach each part with prompting or feedback or fading those supports, but it also allows us to see where our students are struggling, and then be able to provide more explicit instruction there.
All right, we ready to talk about algebra today, right? Right? Algebra is a math that we use to solve problems. And today we're going to solve a problem about gift certificates for the movies. Have you all been to the movies?
Yes.
Have you ever gotten a gift certificate from someone?
No.
How about you, Sumner? Maybe for birthday or Christmas, a gift certificate? Yeah. Gift certificates are something that we use, that people give us, that is we use kind of like money, okay? So today we're going to try to solve this story, all right? So let's read together, starting on page 52, about a girl named Irene. Irene wants to buy her friends a movie gift certificate at the mall. A gift certificate is a coupon for someone to use instead of money. Irene already has one gift certificate. She needs to buy more gift certificates for her 6 friends. How many more gift certificates does Irene need to buy? Okay. So what is the problem? What are we trying to solve? What are we trying to solve for X? What's the thing we're trying to figure out in this story?
1.
Sarah says number 1. Let's read number 1. How many more gift certificates does Irene need to buy? And Sarah is correct. That's what we said down here. How many more gift certificates does she need to buy? Remember, we need to think about the facts that we have in the story. So let's listen carefully for the
Fast forward
facts.
just a little bit.
Do you agree? 1. Jabril, do you think it's number 1?
Yes.
Absolutely. So where do we put number 1?
So if you notice, there's a graphic organizer. The teacher prompts the question. And you're going to see if a
She
student doesn't know
needs
what
to buy
she should
more
prompt them.
gift certificates for her 6 friends. So do we know how many more she needs to buy? Or is that what we're trying to solve? Okay. So do we know what our second fact is? Do we know what that information is? Do we know this? Should this be X? Is that what we're trying to figure out?
They weren't
So
sure,
let's
they
go
weren't
ahead and
answering,
put
so she kind of goes
X
through.
where it belongs.
And at that point, she's giving them a verbal prompt. So the students go back through, they go back, they identify
6,
the
you're
facts from
absolutely
the story,
red chip on.
and then they're going to calculate
6, good job. And all
difference
3 of
using
you
their
have
number
it on
line.
6, don't you? So if we know that our first fact is number 1, let's read what we have here for
read their equation, they solve for
So
X.
when we did algebra, we had to solve for X. And what is X?
5.
5, absolutely. So let's say
So breaking apart a task can be a really great strategy for us to think about, especially when we look at a lot of the skills that are being taught in a general or special education classroom. And so one of the things that happens, I think, a lot of times is we might create some sort of IEP goal or some sort of prerequisite goal, or even a general curriculum aligned goal in a 3rd grade, 4th grade, 8th grade classroom. And the goal is for the student to solve an algebra equation with missing facts using addition. And we think about that as discrete. And so we collect data and it's like, nope, didn't do it this time. Nope, didn't do it this time. But we can't then break it apart. Once we break it apart, we start to see what parts are they getting? What parts are they not getting? Where does the additional instruction needs to happen? And that allows us to then think about what are the skills or what are the very discrete skills that need more practice. And so it might be the fact of the student doesn't know how to use a number line, or it might be the fact of the student doesn't know the concept of more or less, or that they actually can't make a set of 6. consistently, and that's getting in the way of them being able to use manipulatives to solve the problem. And so those are kind of those early numeracy skills that were mentioned when I asked what are some of the barriers. I know that for a lot of our students, and we know from alternate assessment data, that a lot of our students are focusing a lot of their goals, whether it's kindergarten all the way through 12th graders, are still heavily focused on these early numeracy skills of number identification, the concept of putting sets together, making sets, using number lines, concepts of more and less, rote counting. And so we are heavily still focused on these things. But what we also know is that we are also trying to teach grade aligned mathematical concepts. And so as we look at both of those things together, it is a barrier. If our students don't have these early numeracy skills and or are still working on them, how do we embed those both into our general curriculum content lessons, and those lessons might be in inclusive classrooms? So we need to think about the use of task analysis to both break apart how we do something and or the process in which we want our students to do that. And so I thought, one of the concepts that one of the comments that came up in the discussion at the very beginning was this idea both of early numeracy skills that our students don't have or are still working on, the prerequisite skills, but also this idea of building conceptual understanding and inquiry, which I would interpret in mathematics to be that problem solving process. And so we want that problem solving to be happening in classrooms, not just kids regurgitating numbers, or just holding up flashcards and telling me which one's the number 3, or just making sets of the colored bears or the colors fruit or whatever we have in our classroom, but really making it meaningful. And that means that we need to take the general curriculum content and the concepts that are taught in 3rd grade, 4th grade, and 5th grade, and then be able to really think about the processes and the problem solving and how we give our kids an opportunity to both be engaged in those, but not forget about the direct, explicit, repeated practice they need in these early numeracy skills that are going to be really important in their independence. So we use our prompting hierarchy. You saw that a little bit, but these are the things that we know are evidence and research-based, using prompting hierarchies like least to most, our system of least prompts, using time delay, and using task analysis. And so as we use these and as we keep using them and we keep showing over and over and over that they work to teach anything, academics, vocational skills, social skills, behavioral skills, but they work to teach math. We don't want to throw the baby out with the bathwater. What we need to do is figure out, what does this look like in our general education classrooms and inclusive classrooms? So, sometimes we say that everyone's welcome in the gen ed classroom, and we have these mixed messages about who, how's, oh, you're welcome here, and oh yeah, we'll figure it out, but I'm going to hire a one-on-one para, and the para will sit in the back of the classroom and do your math with you. It's not really inclusive. And so really thinking about, what does this look like and who is in our general education classroom? And it might be, well, it's the gen ed teacher. It might be paraprofessionals. It might be a special ed teacher, but we also know in many inclusive settings, our special ed teacher is serving multiple students who are in multiple different inclusive classrooms. So that comes to collaboration, and maybe not physically always being there to be the one to implement and support the academics at the moment. And it also means peers. So embedded instruction is defined as explicit, systematic instruction designed to distribute those instructional trials within the ongoing routines and activities of whatever the environment is. So it's really about distributed. So, not all at once, not just quick in the back of the room, but distributed across the lesson or across the activity, across the day, and distributed explicit systematic instruction. So in special education, we'll often use the words massed trials or distributed trials. And so mass trials is where we sit down and we work and we kind of like practice over and over and over. And mass trials have shown to be effective when students are learning at acquisition and initial learning. Distributed trials, though, however, have been shown to facilitate more generalization. And so what the research tends to show us is that we can still acquire an initial new skills, but often students will do them well in that quick trialed moment, but maybe not distribute them across and generalize them. And that's really our whole goal, is that our students gain new skills that they can then generalize across other places. So embedded instruction is an effective strategy that has that uses evidence-based practices for students in the general education classroom, and multiple literature reviews have been done. One that I did, what we found was that these distributed trials can happen in various different times and various different places. I'm curious if you wouldn't mind just putting in the chat box, I'm just curious, is anybody currently using embedded instruction? And if you are in inclusive classrooms, who do you currently have embedding those trials? Is it the special ed teacher, paraprofessional, peers, general education teacher? Who's actually trying to embed some trials in that classroom? I don't see a lot of responses yet, but it might be because you're typing. And it might be because you're not trying it yet, and that's okay. If you are, I'd love to hear in there, so just add that to the chat box. So what we know is that who embeds the instruction, it can be anyone. And we actually have a lot of research to show that peers are really good at it. And sometimes, from my experience, they're the easiest one to maintain the behaviors. We have a lot of things going on in a classroom. And I have found less success, honestly, with special education teachers, just because usually our SPED teacher is serving multiple students in inclusive classrooms. They might be a resource level teacher, and then they might also be supporting the kids while they're out there, but more consultatively. And so what we want to think about is anyone and everyone in that classroom can embed systematic instruction. And there's actually a lot of research on using peers to support all kinds of different academic skills with systematic instruction. And I have a very unscientific idea of why it works so well, which is that they're little and they just don't have as much in their brains as we do, and they are so good at it. You can train them, you can have, like, I had a pizza party, it was a half an hour long, and these kids came in their lunch, they were 6th graders, and I fed them pizza and taught them how to do time delay and least intrusive prompts. Those kids, their fidelity of implementation in the gen ed classroom was like at 100% immediately. I feel like teachers, we just have a lot of other things going on in our brain that we've got to unlearn. And I feel like peers, they catch it so quick. And the research does show that across the fidelity of many other people's research of using peers to implement systematic instruction. So what we know is that embedded instruction is that we've got to identify the goals and objectives. And so kind of going back to what we just talked about before of your barriers, we know that what are the goals or objectives that you're trying to get the kid to learn in this inclusive math classroom. So if I'm in 4th grade class, I am hoping that they are both learning something aligned to the general curriculum. So it's the 4th grade standards on perimeter, and I want my students to, whatever the alternate achievement standard would be for that, which might be that they understand that perimeter is the outside around, and maybe, the bonus kind of goal there is that the student can add together the sides using a graphic organizer. And a calculator, something like that. So they understand conceptually what perimeter is, and they understand that it can be calculated, and maybe they can use it for something, or they can recognize if they have enough of the material to line the garden or not enough, kind of something like that. So that might be one of my goals. My other goal might be that my students right now don't know how to add. So the fact of them putting the number 2 plus the number 2 plus the number 4 plus the number 3 into a calculator is another goal. So that's kind of like a prerequisite or a different type of math goal that typically fourth graders would know, but my kiddo doesn't. And this would be a great opportunity to practice it. So now I've got 2 goals. My other goal is that my kiddo right now is not using his assistive technology device very effectively or consistently. And I'm going to make sure that I have his augmentative communication device or some sort of response board where he can answer yes, no questions, and or he can ask for help, or he can communicate socially with the peer next to him to say, hey, buddy, what'd you get? You know, for your answer, I don't know. And so now I've got a communication goal. So I'm identifying what I want to explicitly teach. Sometimes I hear people say, oh, I want kids in the inclusive classroom for the social reasons, but the student has social deficit, goals that you're working on. Are you explicitly teaching them and providing opportunities very intentionally and with feedback and explicit instruction while you're in that classroom? Or are you only practicing them in the, self-contained classroom and then hoping that they generalize? That hoping isn't enough. And so we want to figure out what are the goals, and then we're going to identify where the kiddo is at and then how often. So I'm going to kind of go through that process. And again, you can go back to that slide in your handouts to look at kind of the process. But we want to prepare, what are you embedding? Figuring out exactly what is it that you want the kid to be able to learn or practice in that inclusive classroom. Specify those goals, but think about it with the team. This is also really important, is where's the general educator and or the paraprofessional? Is everybody in on this discussion? Or is there some sort of planning document that maybe you have where you can go back and say, when we're in math, here's some of the early numeracy things that he's working on in a resource pullout or in the separate classroom or wherever it is, or that he's working on independently in small groups or tier 2 or tier 3 instruction. Here are the grade line content and concepts that he is responsible for. So for many of the students that I work with, they're on alternate achievement standards based for their alternate assessments. And so I'm looking at my standards and I'm looking at what are the extended standards for this student. That is what he's responsible for understanding. That's really important that the whole team knows that. Sometimes our general educators don't know that. So they have students with more extensive support needs in their general education classrooms, but they're not aware of what is the alignment to what this student is being held accountable for. And then those prerequisites, as I mentioned before, and they could be, some basic ideas. What's important for that one concept? Maybe the concept of around isn't something the student really has. It's not vocabulary they're familiar. That's going to be something that's important for them to understand around something when you're going to talk about perimeter, so that might need to be taught explicitly. So thinking about that, those early numeracy and prerequisite math goals, we mentioned them as barriers. Absolutely, they are, but they shouldn't stop us. So I guess they shouldn't be a barrier, meaning that we don't do it because they don't have. And so they are something we should be concerned about and we should be explicitly planning for, but we don't say they can't be part of the gen ed math classroom because they don't have the prerequisites. What we do is think about how can we provide explicit instruction during that math lesson so that they can. So I was going to start off with just a couple, not start off, I guess we're getting towards, the second half of this, but Lachlan, and just give you a couple examples because sometimes that's easier to walk through. So Lachlan's a kindergartner, and during the baseline assessment at the beginning of the year, his teacher realized that he's missing some key concepts and skills regarding like patterning and counting that kids his age typically come to school with. And so although his special ed teacher is also working on some of these skills with him individually, so maybe during like resource pull-out sessions or small group sessions with other kindergartners and like maybe like a tier 2 type support, his general education teacher has also decided that I'm going to figure out how to embed these early numeracy skills into my math lessons so that it gives Lachlan more practice and a chance to keep working on those skills, not just over there when he's with special ed, but when he's with me, we're going to practice them too. And I think, this is just a good rule of thumb, but something that doesn't always happen in our inclusive classrooms. And so here's another example. Fayola's in 10th grade. She has intellectual disabilities and she participates in math instruction with her general education classroom, as well as another transition course that she goes to that is specially designed to look at everyday math in the community. Fayola's math teachers meet quarterly to determine what are the numeracy skills that she would benefit from learning. And here's an example, like rounding to the nearest dollar, or maybe some calculator skills or place value. And then what they determine is what units of work will be covered that quarter that they can embed opportunities in her Algebra 1 and her transition math class. So really thinking about what are these skills that we might be able to do. Some of the pivotal math skills that we might be considering for another student in that perimeter one is really thinking about, as I mentioned, maybe they don't understand the concept of a round. Maybe they don't understand the concept of inside. Those are going to be really important. You can't really talk about perimeter if we're not even understanding this basic concept. So is it that we say the student doesn't have this prerequisite of around, therefore they can't get the concept of perimeter, or they need to get around first, then we'll do perimeter? That's not going to work, and because it's going to really hold us back for a long time. And so really thinking about that, and what are these pivotal math skills? So while systematic instruction can be used to support the learning of all students, we know that repeated practice and explicit systematic instruction is super important. We know that from those literature reviews before, and we've seen it over and over and over. So let's figure out how to really think about embedding those. And I love the comments in the box. They're popping up and I'm kind of reading them around. And yeah, so, thinking about, I love Mitch. The idea is like, I use this concept today, so it's important for our students to have some understanding about it, and we can definitely make it meaningful to our students. So what we want to do is think about team planning. One of the questions you want to ask yourself is, how many trials am I going to embed in my lesson? And Jameson et al. Suggest that you determine these, and they have some suggestions of how many you need to do. My suggestion is that you think about what's feasible, and that you shoot for it, and you may not always make it, or sometimes you'll make it above and beyond. But I think if you hold yourself to, we will always do 5, you start doing weird stuff in your lessons. And so you want it to be as natural as you can. So as a team, I might decide that, I'm going to make sure that there's 3 opportunities for the student to make a set of 3. I want the student to recognize around an object 3 times during the lessons each day. And I think that if we were to get them to use their calculator once across the lesson to complete one whole thing, that would be appropriate. It may not work to do it, 6 times. So an example here might be is that we have 2 learning goals that we've identified during this math lesson. I'm going to embed 5 times of each across the entire lesson. Or, and here's an example of who's going to embed it. I'm going to have the math teacher knows what these are, and they're going to try to embed them. I've got a couple different students, peers that could do this. And then, I have 3 students in this one math class who could benefit from these embedded opportunities. And then I've got a general educator and a paraeducator. And so each of these 3 students have been identified by the special ed and gen ed teacher to need this extra repeated practice of whatever these couple skills are. They also are getting additional support, like a tier 3 support. But I'm also going to make sure that we put it into our gen ed lessons, and the paraprofessional and general educator make a plan to embed at least 5 trials across the math lessons. And that way the student is getting more practice, they're getting error correction, and they're getting feedback over and over and over, knowing that the special ed teacher is also doing it at another time of the day. This is a chance to give that student more practice and a chance to, generalize those skills. And so here's another example of Lachlan. So if we go back to Lachlan in kindergarten, we're doing a geometry unit on analyzing and comparing 2- and 3-dimensional shapes. During the lesson, multiple shapes will be placed, on the classroom smartboard for the students to analyze, describe, and compare. So that's what the teacher is, in a nutshell, doing in the general education kindergarten classroom. So what we might decide is that we're going to embed at least 3 opportunities for each one of the goals that Lachlan is going to be working on that we've identified. Those goals that he struggles with still, that other kindergartners may not need a lot of repeated practice, but it's not going to hurt them to get a little repeated practice, is identifying patterns, making sets, and rote counting. And so during each one of the math lessons, we're going to embed 3 opportunities for each one of these goals. So he'll have 3 different times across this 40-minute lesson to identify the pattern. He'll also have 3 different opportunities to make a set up to whatever it is that he's working on. Let's say it sets to 10, and to rote count to 10. And then we have 2 more opportunities that we're going to practice to make, that's kind of a, 2 more practices to make sets. And we're going to practice those during other parts outside of the math lesson, during transitions and natural opportunities. So, we were getting ready for something in writing, and I asked him if he could please, count out a set of 4 pencils for his group. And so I know this is a goal of his special ed teacher is working on it, maybe with another curriculum she's using in a resource classroom. We're also embedding opportunities in his gen ed classroom. And then we're also going to make sure that everybody on the team's recognizing there's lots of natural opportunities to practice this. And so we can identify what kind of instructional strategy we want to use to teach each one of these things. And so, what kind of procedure might we use for identifying a pattern? So, for example, here, the natural cue is which one of these sets are in a pattern. And he gets it correct, I give him a verbal feedback. If he doesn't, I give him the next level of support, which is a non-specific verbal. So this is a least to most prompting hierarchy that we saw at the beginning, which is an evidence-based practice. So this is also something to think about with your teams, making sure that whoever's embedding is familiar with this type of procedure. So your special ed teacher might be, but is your paraprofessional, is your general educator, is the peer. And so making sure that there's consistent ways that we provide that prompting and feedback. What I often see in classrooms is a teacher will say, which one of these is a pattern? And when the student doesn't know, they go, this one is a pattern, look, red, green, red, green. So they just went from a natural cue all the way down to the model. What we want to do is provide students opportunities to, build their independence, and we can fade our supports much better when we use a least to most prompting system. And I'm a big cheerleader for really just having like 3 or so levels. I think when you get to too many, it's hard to do it consistently across people. So a really easy one to think about is like non-specific verbal, and then maybe a model. Most kids will respond to these type of verbal prompts. If not, you can always add picture cues, you can add other ones. But once you've kind of shown them what to do with a model, most kids will respond. And if they don't, guess what? You move on, because you're going to embed a bunch more trials of this. So it's meant to be quick. And when you're doing this, this is not bad for other students to engage in as well, even if they already know it. Non-specific, great question. Non-specific verbal means you're not telling them. So here in this example is look at both sets. Remember, a pattern is a repeating design. Which one is a pattern? I verbally prompted you, but it's different than being specific, like saying, look, this one is a square, circle, square, triangle. Look at this one, it's a square, like I'm telling them the pattern or not pattern. So sometimes we use verbal prompts and we tell kids the answers, where a non-specific verbal could be anything from look at your options, remember to check your word wall. And so those are really great things, and actually something I look back when I was teaching and probably didn't do enough. I probably jumped to a very, like I kind of told them the answer in my verbal, where it's harder to fade. So that's a really, I have my undergraduate students go into a classroom and count the number of times that a teacher jumps to telling the kids the answer opposed to giving a non-specific, or how often they give non-specific. And I think we're all kind of guilty of our verbal prompts usually lead the student to the right answer too much. So it's a really great thing to kind of like up your non-specifics if you can. So I know I'm running out of time a little bit, so I'm going to go a little bit quicker through this because you do have the PowerPoint to go back to refer to. And this is one of the templates I gave you for planning, and it's blank if you want to use it. But a template I've used in the past is where I take the student, I take the standard that I want them to work on, because that should be one of my biggest things. And then I think about what is the objective of what that student needs to be able to do. Then what I do is I think about what are pivotal like concepts that the kid's going to need to be able to understand and move forward. It's interesting, even in general education classroom, because sometimes we assume the kids know these things or know the language, and they don't. So it's going to be really hard to look at proportion and relationships if the kids don't understand some basic concepts like even whole and half or more and less. So that might be something that's like pivotal for them to understand. Are there any communication goals that the kid needs to be working on, just in general? Are there specific behavioral goals that they need to be working on in general? And are there early numeracy skills that need to come into here? So if there are, like, for example, times the hour, can I think about ways to look at other relationships in this of fractions or time to the half hour? Or are there other things that are just the kids working on that I can embed into this? And so when I start to think about that, then what I want to do, sorry, let me go back. And I can go over here and think about what is the best procedure that I could embed it in. Should I use time delay? Should I use least intrusive prompting? Should I task analyze this and then prompt the kids through that procedure? What would be the way I would teach it? So it's not just the what they need to know, but it's the how am I going to help them get there? And then this might look different, but this is also one of the handouts you have. In some of our research, what we've done is use this, like where I have the teacher break apart their lesson, the gen ed teacher, thinking about the lesson components. And whatever their lesson component is, I have them think about what of those goals could be embedded when. This is really helpful for paraprofessionals. So when the teacher gets to this like group activity, small group part of the lesson, the paraprofessional knows that, oh, this is a really good opportunity for them to use their graphic organizer and make a set. And that way, it's a good opportunity to practice that early numeracy skill. And it's a good, like, this is when the teacher thinks it might happen. And we've really talked with our paraprofessionals and our teams to say, that's great that you came up with like an overall plan, but seize the moment. If there's something in the lesson and it makes sense to practice a skill again, go for it. The more practice, the better. But at least it gives you kind of an outline of when we might be able to embed and when we might be able to. It's the reason we do lesson plans. We don't read them from the beginning to the end, but it's that pre-planning that kind of gets a plan in my mind of what I want this to look like when. And so really thinking about how we might be able to do this, I put in your handouts, there is a research study that I know everyone's like, oh yay, a research study, but it does talk about the thought process around using embedded instruction within an MTSS model for students with extensive support needs. And that's where this comes from. So you can dig a little bit deeper, but really thinking about how we can provide our students early numeracy instruction as part of their like tier 3 special ed type services. But we could also provide early numeracy in small group breakouts, but also through embedded instruction, we might be able to provide it during the general education lessons, which is kind of a tier 2 support because it's individualized. So this is just an example of going back to Fayola. And, one of the goals that she was working on was looking at like a place value and rounding to the nearest dollar. And so what her team did was they created this data sheet and they actually put it up on Google. This is a real story. They put it up on Google Drive in a folder, and the teachers would log in and add their data when they were working with her in both the Algebra 1 classroom and or in the transition math classroom. They would add their data in there, and that way the team could come back and show how often she was getting opportunities to either practice this or the data kind of showing like, is she generalizing the skill across these two settings? And then what they were able to do is from her goals, they were able to track her progress over time across settings to look at how she was doing. So this is a task analysis of her using her cell phone calculator to add or subtract two price differences up to $10. And so it's really cool to see that the team was able to show. So at any moment, either teacher could kind of come in and be like, oh, cool, she's doing it in both places. And so over time, we want to fade our embedded instruction. And so this just kind of goes through that idea of how you might start off embedding a lot of opportunities for whatever this math skill is in your gen ed classroom. But over time, you can fade that. And that way the student isn't having all this explicit instruction all the time, but starting to show generalization. And this is just what we do with good teaching, is we don't go from teaching it, they got it, and then we just stop. We need to come back and make sure that they're, using it, that they're fluent, that they maintain it, and that they generalize. So I've got just a few minutes, and I kind of wanted to walk through research study super quick that you guys can kind of see what this looked like in action. So what we ended up doing was kind of based on that idea that we talked about at the beginning, is the kids had extensive support needs. We were curious if they had a bunch of early numeracy skills that they didn't know, and they were in elementary school across the grade levels from kindergarten through 5th. And currently what was happening was each one of the students had a general educator that they went to math for, say where they were in the general education math classroom. They also had a special education teacher that they saw multiple times a week in a pullout type setting. And then they had a paraprofessional who pretty much followed them around. So what we were interested in, and I put this in here on purpose because I wanted you to see that this all happened in 3 months. What we saw was that they needed early numeracy skills, and they were really important. And they we wanted to use early numeracy instruction using those evidence-based practices and using story-based lessons. But what we were currently seeing in the general education classroom was that the students were in the inclusive classroom for 80% or more of the day. And these were students with moderate to severe intellectual disabilities and autism. But they had the pull-out resource support. And when they went to the resource teacher would be working on their early numeracy IEP goals for the most part. So things like number ID, things like row counting, and we made sure that the students in the study were all students who didn't already have these skills. So things like row counting to 10, number ID 1 through 10, they were very basic early numeracy skills. But what was happening was when the team would meet, they would primarily talk about the schedule, like when was the kid going to get pulled out for PT, OT, like that's the type of conversation that was happening. And they asked us to come in to support kind of like the next level of how to support these kids. And there are some studies in math and embedded instruction in high school. I'm referring to a question in the discussion. This is elementary school, but in high school, there are some studies using embedded instruction in high school. And if you look at the two literature reviews that I mentioned, the Jimenez and Kamei and I think it's like McDonald et al. Ones at the beginning, they both will show you like elementary, middle, and high school and what subject areas. So what we did was we used, in this one, we used a curriculum that was developed for early numeracy for kids with moderate and severe disabilities, but was very specific, usually to either like a tier 2 group using it or tier 3, like a special education classroom. And that's primarily who had to use this. It was, it's an explicit instruction program that is thematic, that looks at scripted lessons for the teachers to support them using evidence-based practices like systematic instruction. But in that part of that curriculum, it does look at math objectives that you could embed. And so what we did was we took the math objectives from this early numeracy curriculum that was happening in the resource classroom. So we taught the resource teacher how to use this. She taught these units in her separate resource pullout, which was 30 minutes, I think twice a week. That's it. Not during math lessons in the gen ed classroom. And what the team did was they used those math objectives and then they decided when they would embed them in the gen ed lessons, how they would embed them. So what type of prompting, and then they had something to use to collect data on, did the student do it independently? Did they need a level of prompting? Did they, need error correction? And so they did this across unit 1 of the curriculum. So I'm going to show you really quickly. And we asked them to embed those early numeracy skills, at least 4 of those early numeracy skills during their lessons. I can show you a quick clip.
You guys had
A long video, so I'll show you a good one.
I was making hot
eraser. Look, there's one right there.
I'm ready for
Now we're going to.
I'm ready for it.
Uh-oh, Brownie. How about instead of telling me, show me with your actions. Okay? Trevor, show me. I would like for you to draw 5 rectangles. Right?
I don't have an eraser.
We're going to make a set of 5.
I don't have
One
an
at a time.
eraser. I know. Yeah, I know. Five.
3, 4, 5. Let's count. Touch.
I think it's
So we had 5. Show me on your fingers. Show me 5.
So if you notice, that's the general education teacher. She's got a group of a bunch of kindergartners. She's asked everybody to draw 5. For him, she's using, there's a couple things I would tweak. I would have more than 5 in my hand. And so this is at the 0 delay round. She is putting out 5 and then she has them count them. She does it full, like it's the highest level at the beginning. And then she has him find the number 5 out of multiple choices. So she's just embedded, making a set of 5, counting out tangible objects and number ID. So she just did 3 different of his math goals and she embedded them in, I think it's like somewhere around like 35 seconds in the middle of her lesson. She does this across her entire lesson and it only takes a second while she's having everybody else draw 5. And so this is a great example of a general education teacher trying. There's some things with the systematic instruction, but this is at the beginning of the unit where she is explicitly embedding early numeracy skills that this child needs in the context of her general education math lesson. And so that's generally really kind of what we're looking for. At the end of working with these teachers, what was really cool is that what we found was that when the kids were pulled out, they worked on the early numeracy, very explicit program that was specially designed for this population of kids. And those kids did learn these math skills. The embedded instruction of those early numeracy skills. And what we found was the team planning changed. The team now started using formative data collection. They made database decisions. It was based on the goals that the student was needing, not just where he needed to be with who at what point, which was a very different conversation. This just shows that all the students kind of where they started off with their early numeracy skills and where they ended after 3 months. One of the cool things to look at is Kyle is our student, I think that was in 5th grade. Kyle had like just about no consistent, 2 consistent early numeracy skills in 4th grade. And 3 months later, he already was up to 5 very consistently. So that's quite a bit of growth if you think about it. And Sammy was the one we just saw at the end. Sammy like had none at the beginning, and he was independently responding correctly. By 3 months later, up to 7 goals consistently. So this is huge growth in a very small amount of time. And what we found is that our teachers were able to embed anywhere from like 0, the kids were 0 independent responding, all the way up to sometimes 63 and 64%, 88% correct responses in the gen ed classroom, which was really cool to see how they put them across the lessons. And really what we found at the very end was this gave our teachers an opportunity to not only practice those early numeracy skills in isolation, which they might have needed some of those masked trials and repeated practice, but they needed it repeated more often across all the lessons. And so I did put in a couple extra suggested resources if you're really interested. I know this is super quick. You've got some handouts that you can refer to, and these are other resources that you might be interested in that talk about embedded instruction and math instruction for students with high school and maybe even going a little bit deeper. The Jameson book is really good. And I did put the money on there because I just wanted you guys to see these are kind of quick, easy, cheap resources that you might find useful, besides reading research studies, which can be a little dry. So I know we're just about out of time, and I didn't see any questions in the question and answer, but I'm happy to answer a question if we've got 1 or 2 minutes. I see a question here from Rachel. At the middle school level, do I find resistance from gen ed math teachers to modify lesson plans? So look, I think there's resistance, and then there's cheerleaders across all 3 levels of education. I think one of the things that I will say is that if you're interested in trying to do some embedded instruction, one of the things to really think about is, I always, this sounds mean, go with your low-hanging fruit. Look for your teachers who are your friends. Look for the people who are easy to collaborate with, and really think about who are those people who might want to play with this idea with you to try, whether it be in math, science, English language arts, any subject area. And you can also use the same principles we talked about today in any setting. So think about within your own special education lessons. Are you embedding those prerequisite and early numeracy skills in your general curriculum aligned alternate achievement standards, but no, I don't necessarily find any more resistance from middle school about, doing that. But I think that when you get good general educators, kids, even without disabilities, are missing some of these skills. So this is a really good way to kind of look at how we're approaching our lessons for kids with and without disabilities. Thank you guys so much. It's been great to spend this early afternoon with you.